Alright guys, this video is 6-7, which is solving radical equations and inequalities. Pretty simple basic set of rules for solving radical equations. Step 1 is going to be isolate the radical on one side. As long as you get one radical isolated, you're good, especially in cases where there could be multiple radicals. So as long as you isolate one of the radicals, you're good. Number 2. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. For example, if you're dealing with square roots, you'll square both sides. If you're dealing with cube roots, you cube both sides, so on and so forth. Step 3, solve the resulting polynomial equation. And the most important 3 words on the slide are right there. Check your results. So as far as the algebra goes, I mean, it's going to be kind of a short lesson because I'm going to honestly fly through the algebra of it because it at its core it is just solving equations, which is something you guys should know how to do pretty simply now. So like I said on the slide, the first step is to isolate. So you have the square root of x plus 2 in the radical. You have a plus 4 on the outside of it. So your first step is going to be to get rid of that 4. So you're going to subtract 4 from both sides, which gives you the square root of x plus 2, which equals 3. Now this is the step where you have it isolated. So you're going to raise it to a power. Since you have a square root, you'll want to square both sides, which leaves you x plus 2 equals 9, and then obviously x equals 7. So the algebra to it is not terrible, nor will it be at any point in the lesson. The only thing you need to make sure you do, like I said, is check your work. Check that solution out. So I'm going to write it out this time, and I'm going to write it out most of the video. Towards the end, I won't. Okay, so 7 plus 2, you get 9 plus 4 equals 7. Square root of 9 is 3. Plus 4 equals 7. So you get 7 equals 7. So that checks out. So you're good there. It's important to check these. Most of them will work. Some of them will not. With a possible segue to here. So number 2. This is what I was talking about in that set and that rules where, as long as you have one isolated, you're fine. You can go ahead and square both sides, and the key word to that is sides. So you square the entire side over here of 2 minus the square root of x, which means you're going to FOIL that out. You have x minus 12 on the left equals, remember FOIL it, so 4 minus 4 square root of x, and then plus x, because square root of x times square root of x gives you x. Now this is kind of the funny example, haha. If you look, there's a couple different things that you should notice. Number 1, you have x's on both sides of the equation now. That's no big deal. They're like terms, subtract them, and they cancel. Second thing you should notice is that you have an extra radical. And when that happens, all you really need to do is just go through your process again. Okay, so just go through it one more time. That comes from the fact that you had to FOIL up here. So since you had to FOIL up here, you're going to have that square root not disappear on this side of the equation. So just go through your whole process again. Isolate, so subtract 4. Divide by negative 4 there, so 4 equals the square root of x. And now square it so you get 16 equals x. And it's a problem like this where it's definitely vital to check to make sure you got a good solution. So you have square root of 16 minus 12 equals 2 minus the square root of 16. So you have the square root 4. Sorry, hiccups are hitting me right now. Not good for a video. So you have 2 minus 4, which gives you 2 equals negative 2. So as you can see, 16 gives you a false solution or a false statement when you plug it back in. So your answer here is no solution. It's most common going to happen when you FOIL like this. Doesn't necessarily mean every time you FOIL you have a no solution, and doesn't necessarily mean your only times no solutions happen or when you FOIL. It's just kind of the more common case of where they do show up. So kind of moving, like I said, a little faster since it is at the core, you know, a solving equations lesson. So here we go with this. So we have 2 parentheses 6x minus 3 to the 1/3 power minus 4 equals 0. So this one, like I said, if you want to treat it, you don't have to convert from rational exponents to radicals. Just know that whatever is being included in the parentheses of your rational exponent, that's what's considered to be, quote, under the radical. So that's what you want to isolate. So we want to isolate the 6x minus 3 term. So the first thing we're going to do is add 4. And then we're going to divide by 2. Alright, now this is where we're going to raise it to a power to get rid of this fraction here. So to get rid of that 1/3, you got to cube both sides. Your left side will leave you with just 6x minus 3. The right side will give you 8. I'm going to add that 3 over. You get 6x equals 11. Divide by 6, x equals 11/6. And if you go back, you check it, and then you'll find out that it does check out. So like I said, I'm going to show you some of them, not all of them. I get to be lazy. Okay, so I'm going to let you guys go ahead and try this one. Go ahead and try it. Work will be up here in a little bit. Alright, so you go through, you should get 727s down there at the end. The only part to be careful with is, I didn't show that step. Whenever you cube, or at least that little bit of work, when you cube 2/3 right there, remember you got to cube the top and the bottom. So 2 times 2 times 2 gives you 8, 3 times 3 times 3 gives you 27. And then check it, and it checks out. Sometimes the checks will be nice, like I think the last check was pretty decent because you had 6 in the denominator and a 6 in the numerator when you multiplied, so that check was pretty decent. This check is not. This check is fairly ugly. So just kind of take your time with it. Sometimes the ugly checks, I know it's an ugly check, guys, but like I said, the ugly checks are going to be where I get you as far as, you don't want to check it, and I bet you it's okay. Sometimes they won't be. So you have to check each one. Alright, last couple of slides rather. We're going to do inequalities with these. Not a lot, just a couple. Mix it in there. Radical inequality is obviously it's a variable in the radicand and an inequality sign. To solve radical inequalities, complete the following steps. Step 1. If the index of the root is even, identify the values of the variable for which the radicand is non-negative. So we'll do that in the first one. Step 2, solve the inequality algebraically. Step 3, test the values, check solution. So the only place this is kind of different is with it being even. So you have, for an example, 3 plus the square root of 5x minus 10 being less than or equal to 8. So step 1 says, if it's even, see what values are non-negative, which for that means you have to make sure and find out what part of the radicand is bigger than or equal to 0. So we take the radicand, we split it off to the side, we solve it for when it's bigger than or equal to 0. So you get 5x is greater than or equal to 10, and we get x is greater than or equal to 2. Alright, so that's step 1. Step 2, we're going to go ahead and solve this, what we're given, using, your normal algebra stuff. So the same thing we've been doing, just subtract 3 from both sides, you get the square root, 5x minus 10, less than or equal to 5. Go ahead and square both sides, you get 5x minus 10 is less than or equal to 25. Add that 10 over. divide by 5, so you get x is less than or equal to 7. Now the way this sets up is if you can read the inequalities, you have x being greater than or equal to 2, you have x being less than or equal to 7. That sets up as an and inequality. So that's the way you're going to set it up in your answer. So you have 2 less than or equal to x less than or equal to 7. And you want to check it and make sure that you know that's actually what the answer is going to be. Let me move this just up a little bit out of the way of the logo. Much better. So you want to pick numbers when it says test your solutions. You want to go back and pick numbers that are like on the 3 sides of the range. So you want to pick something that's this side of it, in the middle, and then this side. So the book goes at 0 for the left side, the part of it, 4 for the middle part, and then 9 for the end part. So I'm just going to kind of talk through it. I'm not really going to write it out, so hopefully you're listening. You plug 0 in here, you get 5 times 0, which gives you 0, and then 0 minus 10, which gives you negative 10. It's going to be the square root of negative 10, which is an imaginary, which does not less than or equal to 8, so you can throw this out. If you plug in 4, you're going to get 20 minus 10, the square root of 10, and then you're going to add 3 to that. So that's going to end up being about 6.16 when you do it in your calculator, when you plug 4 in, and that's less than or equal to 8, so that checks out. And then for 9, same way, you're going to plug 9 in here, 9 times 5 minus 10, and then square root to add 3. That's going to end up being about 8.92, and that's bigger than 8, so it's not less than, so it can't be. So you know this confirms that your answer is that inequality 2 less than or equal to x less than or equal to 7. Alrighty guys, that's it for this one. Thankfully, it was a little bit shorter than the past few have been. Sorry about that for this chapter, but like I said earlier, you know, there's a lot of stuff to go through with this chapter. Final assignment for this one is going to be page 433. Actually, it'll end up being page 432. Changed the assignment since last year. It'll be page 432, 1 through 21 odd.